Hi y'all, this is going to be a review of Unit 6, which is graphing trig functions. So remember, this is just a really brief overview of everything that happened in this unit. Another good place to go is your My Math Lab quiz, and also working through the review, which are some of the questions that I pulled from this for this video, but there is an answer key involved, so that way you can go through and check your work. So let's get started. Remember, this is the most important equation for this entire unit. We have several different things happening in here. The first are these outside pieces, which are going to affect your y-axis. Remember that your c value is going to affect your sinusoidal axis, or where all of your middle, wow, that's like one word, or where all of your middle points are. So that's that vertical shift up or down. It'll tell you where all of your middle points are. Your A value is going to affect your amplitude, which is actually just that vertical stretch or shrink. It'll tell you how tall your graph is. This is true for any sine or cosine graph. The B value, remember, affects, I'm going to use a different color. The B value affects your period. It is not your period. It just affects your period. It's telling you about that horizontal shift. So when you look here, this one is going to always be, if we're in radians, we're going to take 2 pi divided by whatever that compression is, and that will tell me what my period is. Okay, this D value is also known as your phase shift. Basically, it tells you where is your first point. On the x-axis. So anything I marked in pink is with your x-axis. Anything with purple, that's your y-axis, things that are affecting there. Okay, remember your first point for a sine graph is going to be a middle point going up, and for your cosine graph should be a top point unless there is some sort of reflection. Okay, so let's talk what happened in 6.1. That was like brief overview. 6.1 and 6.2. The first thing we did in 6.1 was talk about the parent functions for both sine and cosine. So we needed to know what these looked like before we could apply any of these transformations. So the thing with the sine parent function, the cosine parent function, is they're actually just phase shifts of one another. They are the same graph. All that's happened is I've moved 1 over pi over 2 units. Okay, so these are the same thing. Like, you're not going crazy. They look generally the same. It's just where they start is what's different. So for the sine parent function, remember your amplitude is going to be 1. So it's going to go up from these middle points, up 1 or down 1. Okay, you're going to have one cycle, one period is going to be 360 degrees or 2 pi radians. So you can see here, in order to get from this first point to this next exact same point, middle going up, it took me whole 2 pi radians. Okay. We also could use our OIO chart to build this graph. If you needed, what is it at pi? Use your OIO chart. The sine of pi would be 0. The domain and range of this guy, the domain is going to be all real numbers, because surprise, I can plug in any angle into this. It's just going to continuously move on and just be that wave forever, that periodic function. But the range is confined to just be between -1 and 1. So that little snake thing, it's only between -1 and 1. Okay, cosine, almost exactly the same. Again, it just has that phase shift. So instead of starting at that middle point, it's starting up here at a top point. So it still has the amplitude of 1. It still takes an entire 2 pi radians in order to get through a cycle, to get from this point, this top point, up to another top point. And then the domain is all reals, and the range is again -1 to 1. So again, these are going to be exactly the same. Sine just starts at a middle point going up, whereas cosine starts at a top. Cosine looks like a cup. Sine looks like a snake, except for, wow, I totally just missed that graph. Okay, so those are your parent functions. Obviously, if you can look at them and graph them, you can tell me pieces of information about them. Here is, again, that general form that we use for any sort of sine or cosine parent function, or not parent function, but any sine or cosine function with those transformations. The biggest thing to notice here is that this b is factored out. So make sure before you try to do anything like naming your ABCD that you go through and you factor out anything. If there's not, like if this guy has something outside the parentheses, it's good. This guy does not. Okay, and again, the first step I always do when I'm graphing one of these is to go ahead and actually name what these points are, these A, B, C, and D. So before I even do anything, I go through and I label what my values are, so that way I have an idea of where to start. So for this graph, remember your normal graph or your normal equation is going to have c plus a. I'm just going to write cosine since it's a cosine here. X minus d. So check your signs, make sure everything's good here. So my a value would be 4. Remember, you're not going to put that negative in here. This negative tells me something about a reflection, which we will deal with in a moment. Okay, my b value is whatever's in front of those parentheses, so pi over 5. My c value is 5. And my d value, be careful, in the normal equation it's a minus. Here's a plus, so that makes this negative 3. So if I then wanted to graph a cycle of this, I would use these pieces of information. Let me make sure I make a beautiful line instead of something ugly. It's maybe not as pretty as I wanted it. Okay, so when I look at this, again, I usually plot my y pieces first. So your A and your C deal with your y-axis. So I'm going to go ahead and plot my C value on here. This is going to be 5, and that's going to be where all my middle points live. And then I'm going to plot my my A value, which is my amplitude. So 4 above and 4 below are going to tell me where all my highs and lows are. Again, you can count it out on your graph. This is perfect. I understand what's going on, even though it's not marked off. Great. Okay, so now I have half the battle won. My y-axis is labeled. The next piece I'm going to do are anything dealing with my x-axis. Okay, so my x-axis starting point is my d value. Again, your d value also relates to what your graph is. So since this is cosine, it should start at a top point, but there's a reflection. So again, it's going to start at a bottom point because of this minus sign on the outside of the function itself. So at that first point, which is at -3, I don't know why I marked this one off, -3, I'm going to have a bottom point on my graph. Okay. After that, I'm going to use this pi over 5 in order to find the period. So my period is going to be 2 pi. Why am I in radians? Because there's a pi there. 2 pi divided by pi over 5. Okay, if you've forgotten how to divide fractions, you take 2 pi, multiply by the flip of that fraction. Your pi's will cancel. You'll be given 10. Okay, so in order for me to make one full cycle of this, I have to go 10 units. So if I look here, I'm going to go 10, so that would get me to 7. Okay, so I'm going to go start at my down point, have a middle point somewhere, a top point, a middle, and then at 7, I should be back down to that top point, or that bottom point, I guess. Ooh, well, I sort of hit my points. I tried. Okay, again, we're not judging your ability to draw the graph. We're judging your ability to label the axis. The last thing that you're going to need to do is figure out these critical points. Remember, critical points can be found using your period divided by 4. Why 4? Because there are 4 more points after your first point. So in this case, my period is 10. So 10 divided by 4 gets me 2.5. So every 2.5, I'm going to have another point. So this is going to be kind of icky and have a fraction decimal thing. So I'll have a point at -0.5. I'll have a point, oh no, I don't want to get it wrong. You know me and decimals. 4.5. And then what is that? 1? I don't know. Say good idea. Here, man, I think I did mess that up. I think that should be 2. Okay, again, use your calculator if you need to. Now, the hardest part after you've graphed one of these is when you're asked to find things about the graph, like you have amplitude, period. We already know those 2 things, right? My amplitude, we said, was the A value. Pretty straightforward. Okay, period is a little bit tougher. You have to go in and you have to take 2 pi divided by pi over 5. And so in this case, we got 10. Okay, now the other pieces they're going to ask for, just like they used to do in Algebra 2, they're going to ask you for the vertical shift. And they're also going to ask you probably for the phase shift or the horizontal shift. Now, when they ask you for those 2 things, they're usually going to say something units up or down. And then for phase shift, something units left or right. So I know for these 2 particular values, they have a positive or negative on them. The C and the D can have a positive or negative value. But this up and down or left and right business gets rid of the need for putting the negative. So the vertical shift, we said, was my C value. So that's positive 5 units, and since it was positive, it'll be up. If that had been a downward shift, I would have still said 5 units. I would have just said down. This units piece, this little blank, is just asking you for the absolute value of the shift. Okay, same deal for this phase shift. I know that I used a -3. I know I started at -3, but my shift is just 3 units left. Okay, left has told me that I'm going in the negative direction. Okay, again, for the phase shifts or for your shifts in general, you're going to do the absolute value of the shift and then tell me up and down or left and right. Okay, so that's generally how you graph these. There's lots more examples of this on the review. The biggest thing, again, is to remember before you start doing anything, if your little number, your B value, is not outside the parentheses on the inside, you're going to need to factor your argument. I'm not going to graph this one, but in order to factor this, remember, I need this 2 to be outside the parentheses. So if I take a 2 out of this 2x, I'd be left with an x. If I take a 2 out of pi over 4, I would be left with pi over 8. So my phase shift just changed because of that. And again, if I was to distribute back in, I should get the same thing that this started with, that was printed on the paper. So 2 times pi over 8 would get me pi over 4. Okay, again, you have to factor before you start, otherwise you will miss your phase shift. So that's generally graphing. Let's go backwards. If you're writing equations from a graph, for some reason, a lot of people think that this is a little bit more simple. Great, awesome. Okay, remember, A and C are still y related, B and D are x related. To find A, it's a distance from the middle to high or low point, or you can take your high minus low divided by 2. Your C value is the y value of the middle points. Again, if you have the high point and you know what your amplitude is, you can do high minus A. To find B, you use the same formula that we were using for the period. It's just now you're going to take 2 pi divided by the period. It's always 2 pi divided by something. Okay, the period is the x distance from top to top or bottom to bottom, basically from one point to the next point that looks just like it. Your cosine, and then for your d values, your cosine, your d value is the x value of a high point. For a sine, your d value is the x value of a middle point going up. Okay, so if I was to look at a graph like this, pretty not straightforward for everything, but for some pieces it might be easy to look at. Now, the one thing, sometimes it's hard to see the middle points. So again, one of the things that I'll do is I'll look at this and say, okay, I went from 2 to -4. That whole distance is 6. So in order to find the amplitude, I'm going to take that total distance and divide it by 2. So I know that the amplitude, the A value for this is 3, which means that if I want to find my sinusoidal axis, I'm going to use orange, I'm going to go from that top point and I'm going to go down 1, 2, 3. That's where all my middle points should be. So if you're struggling to eyeball it and see where that middle point is, just use that trick. Okay, so then in order for me to find my C value, I took that top point, which was 2, and I just subtracted whatever my A was, which got me to -1. Okay, so my C is going to be -1. Now I'm going to find my period. That's, again, going from a top to top or a bottom to bottom. Basically, whatever is the easiest to find on here. So in order for me to get from a top to a top point, I went pi. So my period of my graph is pi. So in order for me to figure out what my B value is going to be, I'm going to take 2 pi divided by pi. Yay, my pi's canceled. I'm just left with 2. Now, this last part is where your graph is going, or your equation could be different. Okay, so for all of your equations, no matter if you're using sine or cosine or positive sine or negative cosine, whatever, all of this beginning part's going to be the same. I'm going to have C plus A, and then pick whatever you're going to do. I'm going to use cosine. 2 times x minus something. Okay, for all of these is going to be, those 3 numbers are going to stay the same. But now if I'm going to pick a D value, just depends on what I want to find. I said I was going to find a cosine, so I'm going to look for the x value of a top point. I have one at 0. I have one at pi. Okay. If I wanted to write a negative cosine, if I wanted to find that negative, the bottom point, I could use pi over 2. Okay. If I wanted to use sine, I would be looking for a middle point going up. Sometimes these are a little bit harder to find. For instance, this one's not marked off, but there's one at negative pi over 4. There's another one over here at 3 pi over 4. Okay, same deal with the negative signs. You'd be looking for a middle point going down. But all of your equations should look the same up until that D value. So I'm going to use pi since I already wrote a minus in. I could have just left that minus 0 and not written anything, but this is a good equation for this. Again, to choose which graph you're going or what equation you're going to write, it doesn't really matter, okay? I tend to pick cosines because finding top points is way easier for me than finding middle points. If you choose to write everything as a sine equation, that's also okay. Any periodic function that looks like this can be written as a sine or a cosine function. One of the biggest things you have to watch out for, though, let me find an example, is if, well, maybe, nope, there's the equations, is sometimes they're only going to give you half of a period. So if you look at this one's number 3, I believe, on the review, notice that I don't have a top to top. I have a top to bottom measurement that I can do that's half a cycle. So I can then imply that in order for me to get from a top to a bottom, back from a bottom to a top, that's going to be another 2 pi in this case. Okay, so be careful if they only give you half a cycle. Same deal here. If you need to, you can always double or whatever you need to do in quadruple, I guess, if you knew a bottom to a middle. Okay, so again, there are lots and lots and lots of correct answers. A, B, and C should always be the same. Otherwise, you can always write whichever, like this one I wrote as a negative cosine. You could have written it as a positive cosine, so on and so forth. Oh, I don't know what happened there. So that was 6.3. 6.4 are your other trig parent functions, the ugly, crazy ones with all the asymptotes. The things to know about this is what the picture looks like, which one is which. So one of the easiest ways to tell which function is which is to remember that cosecant goes with sine and secant goes with cosine. Okay, so if I was to draw the graph that made this thing, remember, every place where there was an asymptote, there's going to be a point at 0. So here's another one. Here's another one. Those, I'm going to try to connect the dots here, and the bottoms and tops of these little parabolas are actually part of this graph. So if I was to make this equation happen, well, sort of, that graph happen, notice that that blue line is sine. Okay, it goes through the origin. It has the top points at pi over 2. So if the blue line, the line that guided this weird parabola thing to happen, was sine, that makes this one cosecant. Okay, so cosecant it starts at an asymptote. It has the parabolas. Remember, it's going forever, so there's more parabolas going on all over the place. Okay, whereas on this one, if again I'm to connect the dots, again the tops and bottoms of those parabolas, and then those asymptotes are zeros. Notice this one starts at a top point. I was trying to write top, but I wanted to write green. There we go. That's going to be my cosine graph, which would make this one y equals secant x. So if I look here, this one starts at the bottom of a parabola, has those asymptotes every pi over 2. Okay. So again, know what your normal parent functions look like, and it will help you guide your next ones. Now for tangent and cotangent, the biggest things about these two graphs is that one period is just equal to 180 degrees or pi radians. Okay, it starts to repeat itself every pi instead of every 2 pi. So if I look here, the graph of tangent is increasing. Okay, it goes up every time. My little waves go up, whereas my graph of cotangent is decreasing. So cotangent starts at that asymptote and then goes down, whereas tangent starts at that 0 and goes up. So that's kind of how you can help yourself look and see. Oh, I was like, why does it say one period? It means this is one period. Okay, or I guess this like middle to middle thing. Okay, so again, the other trig parent functions aren't super important. We're not going to transform them or anything. Just the thing you have to know about them is what the picture looks like. That's all you need to know. Either draw in your original function or remember that tangent increases and cotangent decreases. Alrighty. Oh, that's right. I was like, what happened here? Who even knows? Here's the part with your calculator. Why is all this stuff just hanging out in here? Those word problems, again, use the same equation. Okay, they use the equation you've been using this whole unit. Now, the thing that's going to happen for me most of the time is I'm going to try to write things as cosine, because for the most part, your problems are going to give you tops and bottoms. They're going to give you mins and maxes more so than they'll give you middles. That's not always true, but it's a pretty good starting point to jump off of. So I'm going to do this problem from the review. It says, assume that as you breathe, the volume of air in your lungs is a sinusoidal function of time. That's good. That means I can draw a periodic function. I'm going to actually start sketching so that way I'm not lost as I'm reading. Okay, so it says suppose that at time equals 2 seconds. So we're looking at volume versus time. So time is 95% of the time on the x-axis. And then I'm going to have the volume in liters. And then I'm going to start plotting what I see in this problem. It says at time equals 2, your lungs have their maximum volume of 3.2 liters. So if I plot that point, time equals 2, I should have the highest point on the graph of 3.2. When you exhale, your lungs still have 0.6 liters. I would hope that you never were completely out of air in your lungs. That would be upsetting. Okay, the last thing, it says your breathing rate is 1 complete breath every 5 seconds. Okay, your rate, your cycle, your completion. This is going to be what my period is. Okay, that 5 seconds. So in order for me to complete 1 full breath, in order for me to get from a high point back to another high point, it's going to take me 5 seconds. So 5 seconds after 2, surprise, is 7. Okay, there's my period. There's where I've used my period, 2 plus 5. So then at this point, I know somewhere in the middle, I'm going to have to get down to that low point of 0.6. So here's a general sketch of what's going on. I'm breathing constantly. So now I can write the equation so then I can type it in my calculator and find information out. So to find the equation, same thing that we were doing before. You're going to need to find your A, your B, your C, and your D. So for A, I'm going to do the shortcut way where I figure out what the height of the whole thing is and then just divide it by 2. So 3.2 minus 0.6. I totally should have a calculator next to me so I don't mess this up. That was me opening my cabinet so I can have a calculator. So that's 2.6. And again, I'm going to take that entire distance, divide by 2 in order to get what the amplitude is. So I know that half of this is 1.3. So after that, in order to find my middle points, I can just take that top point, 3.2, and subtract 1.3. Just trying to make sure I get it right. I get 1.9. So again, what I did here is I took that top point and I subtracted whatever I found for the amplitude. For your period, again, you measure from top to top. I know that that's 5. That's how long it takes for me to complete a cycle. So for my B value, I'm going to take 2 pi divided by 5. You can simplify if you can. That one won't simplify. I'm just going to leave it like that. You could use 360 if you wanted to. Just make sure your calculator's in the correct units. And finally, for the D value, again, D is going to be an X number, something on your x-axis. So I'm going to go ahead and find something that's easy. I want to find that top point. I know that top point's at 2. Okay, I could look for a middle. I could look for this bottom, whatever. I'm going for the easy thing. So if I write all of this into an equation, I have y equals 1.9 plus 1.3 times cosine 2 pi over 5, and then x minus 2. That's just me throwing it at all those numbers I just found into this equation. Okay, once you have this equation, it's really simple, straightforward. Type it in your calculator. Okay, be careful how you type it in. Most of the time it's going to look like this. Don't put too many parentheses in, because now at this point, I can go in and I can find what is it at time equals 0. I can use the table between what 2 positive values of t did your lungs have no more than 1 liter of air. Well, I know that means I need a y equals 1, because that was volume of liters right there. And I can go into my graph and find that. Making the window for this graph is even easier because I have the picture. So when I make this window, make it go at least to 7, the x's, make your y's go up to 3.2, and you can find these pieces out. So I'm not actually going to type it in my calculator right now. I'm going to go cheat and look at my answer key because life. Okay, so again, found the same equation. Cool. So showed you the window that I used. I actually went to 14 to get this graph. You can use your table here, or you can use the trace. You should, once you type in x equals 0, again, make sure you're in radians. If you use 2 pi, your degree is 360. I got 0.848. And then for this next piece, between what two positive values of T did your lung have no more than 1 liter of air? Well, that's here. If you're going to put in y2 equals 1 in your graph, find these two intersection points, and those are the two values where you were underneath 1 liter of air. So 3.859 seconds and 5.141 seconds. Okay, the last type of, as I go through this entire key, the last type of word problem you might see looks like this one, where they actually give you the equation. And I think we've seen this a few times in the My Math Lab. So this one's saying a weight attached to a long spring is being bounced up and down. As it bounces, its distance from the floor varies sinusoidally with time. Awesome, I know that it's periodic. The following equation represents the spring's distance in centimeters as a function of the time elapsed. So they gave you the equation. Cool. A lot of times when you type this into your calculator, you're not going to find the picture. It's going to look weird. It's not going to look like what you want to see. So the first thing you're going to look for is if there's a pi, I'm going to make sure my mode's in radians. Then I'm going to go in and set my window. I have how I found my window right here. So the first thing is if I want to find my y mins and y maxes, that's again going to deal with C and A. So to find your minimums, you're going to take whatever your C value is. In this case, my C value is 50. And I'm going to subtract the amplitude 10. That's going to tell me where my low points are. So 50 minus 10. My y maximum is going to be my C plus my A. So I'm going to take my middle points and add my amplitude. So I'm going to get 40 and 60 to be my y mins and y maxes. Okay, that's pretty straightforward, not that difficult. It's the x's that get a little bit trickier. For this problem, since x is time, I'm going to start at 0. X min is 0. For the most part, it's going to be 0. Now your x max is where it gets a little bit tricky. You can actually type in arithmetic into your window screen. Like if you see here, I typed in arithmetic here. So I'm going to want 2 cycles. This is just arbitrary. I just am trying to find the number, but I'm going to put in 2 cycles multiplied by whatever the period is going to be. And I can find the period by doing 2 pi divided by the b value. In this case, 5 pi over 16. You can do that mental math in your head, whatever, but if you just put it in your calculator, it'll do it for you. Woohoo! So then when you go into your calculator, again, I have it all typed in. I can just go, here's my window. I apparently have 20. And I get something like this. Now, the reason that my graph is probably a little bit bigger than yours is because I knew I needed to get a little bit further out in order to get the whole thing. But again, you can type into your window settings and at least get the idea of the beginning picture. The reason I did this is because it said how high is the weight above the ground after 17.2 seconds. I believe it was like 12 or 13 before. So I knew I needed to get to 17.2. So I went ahead and made my window just a little bigger. It's okay if you're not perfect on the first try. So after that, once you have it graphed, if you want to find after 17.2, you can either go to the table, or if you just hit trace once and type in your x value, that'll get you your first thing. So this will be 43.656. I'm just totally going to be lazy and not even write it down. There's my answer. Okay, and then when does the weight reach 45 centimeters for the third time? So I'm going to go in there. Since 45 centimeters represents a y value, I'm going to do y2 equals 45. Go look at the graph, and I want it where it's hitting the third time. So 1, 2, 3. I want this piece. So I might sketch that out on my paper to show my work if I needed to. I'm going to do second trace, number 5. Going to go get close to that. Oh, man, why did it put me all the way back over there? One day I'll get there. Again, you need to be close to this intersection point. Otherwise, your calculator will give you the other intersections. Here we go. And I'm going to press enter 3 times. And I get that it is about 8.833 seconds. Okay, so that is the general idea of how you can do those types of problems, those word problems. Again, this review is a great review. It has lots and lots of practice problems in it, making equations of graphs, actually graphing things. This guide helps you find the range. Remember, your range are just to your y values. And then I'm like scrolling through. There's a couple of figuring out, making equations, finding maximum values. And then again, you're going to have some word problems near the end. So that way you can practice doing some word problems. Good luck on your Unit 6 test.